set of units of our looking at the universe, naturally, it's not coming from the universe, it's coming from me. Because I am the guy who is being the observer, observing. The fact that I do the science doesn't change the universe, but it does, of course, create my units, my language, my mathematics, everything is, because I have 10 fingers, because I have a meter, etc. So in that sense, it's also real. And this image is the embodiment, the symbol of the statement that man is the measure of all things. This is a drawing by Leonardo da Vinci. Many of you have probably seen this drawing. I discovered from Wikipedia that this is called the Vitruvian Man. Vitruvius was a very famous architect of the Renaissance. And what Leonardo is doing here is he is putting the human body into frames with certain ratios. You see there is a circle. So with the extent of the human body's arms and legs, you can reach a certain area, and that defines a circle. Now a circle is a mathematical abstraction. The human size is just the radius of the circle, so that's very human. But the fact that my legs and arms all reach the same circle means the way my body is produced, that evolution has produced bodies because of the mechanics and the metabolism and so on, has certain proportions, ratios also. When you come to ratios, oran, then it becomes without dimensions, without units. You can refer to certain mathematical and aesthetic concepts. So that's what he's doing there. From the physical measure in meters of man, he is going to ratios. The circle, how far all around can I reach, and the square. Of course, the dimensions of these things, the circle, radius, and the square will be of the order of meters, because that's what my height is. Okay? Now you can go, it is not in this picture, you can go further in when you study biology, physiology, as already early scientists and artists were aware of. You can get other ratios. For example, you can get the golden ratio, altın oran, which is a very important design and aesthetics, but it has also, it's important mathematically, it has an abstract mathematical meaning, and it also shows up a lot in the ratios of biological organisms. Okay? Again, as a ratio. So much for this picture. So our units, our way of looking at the universe, the need to construct a language for communication that relates to the world, and the mathematics that relates to the world, brings us to ourselves as a measure. But when you actually look at the numbers that you write down, this has nothing to do with me. And as a result, the sizes of the universe, small and large, and the time scales can be very large and very small compared to my size. Okay? Now, here's another thing I'd like to show you. How many of you have seen this image before? Okay, so you are a different generation. In the 1960s and 70s, this was very popular, very well known by the public. Those were the days of the early space exploration. That means sending man to the moon, sending spacecraft to the planets. And there was one spacecraft, the Pioneer. This was designed and shot into space by NASA to observe Jupiter and Saturn. So it was put into an orbit shot into space in such a way that it will go past Saturn and then make a deviation past Jupiter and past Neptune. That means it is now very far from the Earth, and it is impossible and extremely expensive and not useful to make it come back to the Earth. Okay? So it was designed so that it goes past Jupiter and past Saturn and sends us pictures and scientific observations of those very far planets, and then it leaves the solar system. Goes past them, away. So it is the first man-made object to leave the solar system. When scientists and engineers were designing this, of course people are always interested, and in those years it was a very hot topic. We are curious if there are other civilizations somewhere. So on the very low chance that maybe this little satellite that we are throwing out of the solar system into essentially vacuum, going very, very far, it will just go on a straight line forever. Okay? Maybe it will be observed, it will be intercepted by some intelligent civilization. So there was a task of how to put there some information so that if another intelligent species gets this thing, they can make sense of it. This is a very intriguing question, how to communicate with them, because of course we don't even know that they exist, but if they do exist, it is guaranteed that they don't look like us. They don't have our type of brain, our type of body. Certainly they don't have our language. It is impossible, scientists reckon, that they don't have mathematics. Mathematics is abstract, it is unique. Okay, you can express it in 10 or 2 or whatever, but abstract mathematics, for example, the series of prime numbers, these kinds of things, is universal. Moreover, any intelligent civilization, no matter how different they are, if they are going to become a civilization and have technology, must have discovered this abstract mathematics. On this assumption. Plus, the universe itself is there, so whatever stars, etc. are there, these guys are also observing. So we can tell them what we are like and where we are by referring to some stars and their signals, and referring to numbers, and first tell them about our number system. So this plot is a very good illustration about man's size, man's scale, and how we are, to what extent we are the measure of everything. Of course, we are not absolutely the measure of everything for other people, but here is a very creative way of telling very briefly with pictures to these extraterrestrial people what we are like. First, of course, there is a picture of us, a man and a woman. If you read the Wikipedia, it's very funny. You should all read it. Because in the first draft, they made the man and woman hold hands. Then they decided, Carl Sagan, how many of you have heard of Carl Sagan? Okay, again, the previous generation, very famous, very good writer of popular science, a bright scientist who was also involved in this effort. Okay. Carl Sagan realized that if you have the man and woman hold hands, a stranger will think they are a single organism. It's because they don't know anything about us. They will just think that it's a funny sort of two-sided object with small differences between the two sides. Right? So they decide, okay, separate, so there are two kinds of us. They know that. Okay. And then behind them is the picture of the spacecraft. So if they actually see physically the spacecraft, they will know our size, how we compare. if they don't see the spacecraft, here is a symbolic picture of the hydrogen molecule. Okay. Why? Because hydrogen is the most common element. If they are civilized, they must know hydrogen. If they have any mathematics, any idea, which they must have, okay, this is a very simple picture, they recognize hydrogen. And then there are some ticks somewhere here, the definition tells you, which tells you in some dimensionless absolute units what is the frequency of basic oscillation of the hydrogen atom, and relates that to our second as numbers. It says somewhere that the numbers here are given in the 0-1 units, which we use in our computers, because 1 and 0, I mean, they would recognize that. So the size of the hydrogen atom, the frequency of the hydrogen atom, those things are given in our units, but compared to absolute natural units, so they know our size, even if they don't catch the satellite. Okay? Then where are we? Here is a picture of the solar system. So this civilization, if they have advanced astronomy, they will have maybe discovered our solar system with all the planets. And it's unique, the sizes of the planets and so on. There won't be another star like it. So that will tell them. Moreover, it tells from the position of the sun, there are these different directions. On each direction, there are some ticks. These refer to certain pulsars. Pulsar is a kind of very energetic star that I am working on also. And their properties, they send out radio waves that have specific periods. Each pulsar is its own period. So which pulsar it is can be recognized by whether it's doing this or what. Okay? So this will help them to spot the sun because it is in such and such directions from this bunch of pulsars, each of which is marked by how fast it ticks. Okay? So this is a way to communicate without assuming any knowledge about our language, anything other than mathematics and science, which must be common to any advanced civilization. Okay. So what this is doing is inverting it in terms of natural scales, the ticking of certain stars, the ticking of hydrogen atom and so on. This is describing us. Okay? I put these on scores, and I would encourage you to read through them. Okay? And now we can have a break, and we'll continue in the next lecture.